we're going to talk about the relationship between position, velocity, speed, and acceleration. In order to help us, we're going to use some calculus, specifically the derivative. Now, the next thing that we're going to move towards deals a lot with understanding what a derivative is and does, because it's going to be a lot of interpretation. So, make sure you ask questions if this doesn't make sense. So, when we talk about the derivative, we use a operator sign, which is usually like dx. Now, I'm going to use ddt because when we talk about real world situations, it's always how do things change based off time, right? So if we think about velocity as like change in position over time, aka I know at a certain time I was at a certain spot, and then at this other point in time I was in this other position. I want to see, well, based off that change in time, how did my position change? How fast were you moving? So that's why we can take the derivative with respect to time of position, which is usually referred to as s of t. Some people refer to x of t. I'm just going to stick to s of t to make it a little easier for us, right? Now, depending on what the equation actually is, we're going to get some other equation to work with. But it's important to know that this represents your velocity function. All right. So whatever we would have gone for our position, that would have been our velocity, because again, we're trying to figure out how fast an object is moving, and that has to take into account whether you're moving in a positive or negative direction. That's velocity. Now, if we're talking about speed and velocity are very similar, but there's an important distinction about them. Speed is the absolute value of velocity. It's telling me how fast is something moving. It doesn't matter if it's moving in a positive or in a negative direction, just how is it moving, right? So you think about speed as the absolute value of the derivative of a position function, all right? I will be available if you guys have questions about this. Just ask, because hopefully this makes sense, especially to some of you physics kids out there. So if I can take the derivative of position to get me velocity, then what if I take the derivative of velocity? All right. So again, using the operator of the derivative with respect to time. But this time we're going to take the derivative of a velocity function. So that's going to give you the acceleration based off time. Because acceleration is saying what's the change in your speed based off time. So how fast is your speed changing? Or I'm sorry, how fast is your velocity changing? Because I said velocity, and there's a difference between speed and velocity. We got to be careful with our words, right? So we can say that this would have to equal acceleration function should equal the derivative of velocity. But remember that velocity was the derivative of the position function. So if I take the derivative of velocity, that's the same as taking the second derivative of your position. Hopefully this helped and made sense of the connection between them.